Good morning, everybody. My name is LEPEMANGOYE, and I'm a PhD student at the University of Bourgogne-Franche-Comté. Today, I'm going to talk about the phenomenon of hydrogen-embrittlement of titanium tubes as used as heat exchangers or seawater desalination systems. The objective is to find a solution to avoid the phenomenon of embrittlement by hydrogen. That is some examples of titanium tubes. The research project is entitled Impact of Hydrogen on the Behavior of Titanium Alloys Welded Tubes. It's in collaboration with two laboratories, ISITE-BFC and UTINAM, and Neotis company. Each partner has different goals. ISITE-BFC, which is to develop the experimental and numerical means to provide its knowledge and skills in the hydrogen fields of titanium alloys. UTINAM wants to improve its knowledge in the implementation on oxide layer. Neotis, which is to reduce the hydrogen absorption capacity of its titanium tubes during their service life. Why is it important to avoid the phenomenon of embrittlement by hydrogen? Titanium alloys has a great affinity with hydrogen. When the quantity of hydrogen increases in the material and the solubility limit reached, we assist to a precipitation of hydride in the material. This hydride modifies the mechanical properties of the material. More hydride in the material, more brittle is the material. Then, microcracks and breaking can appear in the material during the service life. In order not to achieve this phenomenon, we realize different treatments. We distinguish shot peening to introduce the compressive stresses on the surface of material, anodization to create an oxide layer on the surface of material, asymmetrical cold rolling to ward hardening of the material and to change the crystallographic orientation of grain, and heat treatment to recrystallize grains in the material. After this treatment, we carried out hydrogen tests in autoclave located to ISITE-BFC in this condition of temperature, pressure, and solution. We use different technical analysis, such as EBSD, X-ray diffraction, transmission electron microscopy, to characterize how samples before and after each treatment. that is some result obtained since the beginning of this project. We can see that some treatments, such as treatment T1 and treatment T4, reduce the hydrogen absorption capacity of titanium. Also, we can see more hydrogen decreases in the material, less there are a precipitation of hydride in the material, as you can see on the figure C and F, which corresponding to treatment 1, respectively treatment 1 and treatment 4. In addition, we can be that some treatment, as treatment 2 and treatment 3, give orientation specific to hydrides. This is the manufacturing process of titanium tubes at Neotis. The titanium sheet received is uncoiling, forming, welding, next sizing, handling, threading, and cutting at the end of inline tubes welding. In our slide, we can see that where each treatment can be implanted if there are choice or selected as a solution. For this project, we recruited a PhD student, a postdoc, engineer for 6 months, and proposed 4 master's internships. We bought an oil drilling unit for the determination of residual stresses. They have other collaboration with LEM3 laboratory, LASI laboratory, and other countries as SFGP. We participate at different conferences. It's an international conference, and publication has been written. National European conference and 2 national seminars. In 1991, we will participate on other international conference in USA. We have 2 participation. Thank you for attention.